All right, so welcome everyone to the second session of week 4. Um, and first of all, just a quick recap, everyone for their attention. Quick recap of what we did in the last session was series of transformations which we did with formula in data IQ. We also looked at the sampling where we said, you need to look at the sample versus the population in order to make sure what data IQ is looking at. I hope you will get a chance to practice this later. Okay. The only thing that you need to do is whatever we are doing in class, just find time, half an hour, 45 minutes, other than the class. Repeat whatever we have done. Make sure you're comfortable with formulas. Make sure you're comfortable with treating missing values. Make sure you're comfortable with prepare recipe, data transformation, etc., etc., and you are comfortable with data IQ. Last class, I've already mentioned about the coursework, which is the hackathon as well as the main project that you will be doing. And if there are any questions before I tell you the agenda for today, please let me know. All good over there? We don't need it right now, so all okay. No need for data IQ today, so I'll tell you what the agenda is. So any questions? Any questions anyone has for the module, for anything that we have covered? Yeah. Did we record the last session? We did record the last session, yes. Even this one is being recorded. Yeah. Anything else? Anyone? All good, shall we proceed? Yeah. I heard so, yeah. Probably not, because I tell you, I think the hackathon which is being planned is mainly for the use of AI tools, which means, all the new AI tools which are there, how to use it, how to build, let's say, a website using Claude and things like that. But probably not much related to the actual AI algorithms and actual AI development. So I heard from Mariam, I think that you have something on Friday. But yeah, again, that's something which is added on as a value, whatever you learn, it's already good for you. Anything else? Any other questions anyone has?
Have they answered the recording?
So recording, by the way, for those who have only attended on campus and have not attended online, just to tell you, this is how it looks like, the channel. So if you look at lectures and seminar channel, you see every meeting link is a different one. We haven't recorded everything, but for example, if you want to see the last one, come in, which is, let's say 23rd June. Yeah, there you go. So 23rd June, if you see the chats somewhere here, there you go. So that's the recording. So just click on the link, you'll find the recording. Okay. Great. So agenda for today is, as you know, starting next week onwards, we will be starting the 4 algorithms of the AI modeling. So next week, we'll be starting with logistic regression. We'll move on to decision trees. We'll be doing unsupervised learning, etc., etc. So before we get into the series of AI algorithms, today we will look at something more fundamental. And that's why I was saying we'll take a break from data IQ. And we will focus on regression as a method, which officially is not part of the module, but then I want to make sure that you understand regression so that we can actually go for AI algorithms like logistic regression and so on. And fundamentally, it's very, very important to know regression as a base method. From a prediction point of view, from a forecasting point of view, it's important to know this algorithm so that all the other algorithms you will do subsequently. Do remember, regression for today's session, we will use only Excel. Everything can be done in Excel because I fundamentally want you to get stronger on the algorithm. And then next algorithm onwards, we implement everything from big data, please. Okay, so you don't need data IQ access for today. And as I said, probably the last week for the foundational elements. So we actually start with the algorithms next week. The first one is not All right, so if everyone is ready, shall we get started with regression? Yeah, right. Now, what I want you to get prepared with is just have Excel on your PCs. Data I will give you later. I will first do some explanation of the algorithm. Then I will give you data. Then you will have your own time to do it. And then we will just go on increasing the complexity of regression. And at the end of the session, there will be a forecasting challenge, which all of you will be attempting. You will see who is the best forecaster in house. So that's where we are building up to. We'll start small, we'll increase the complexity, we'll understand the tips and tricks of regression, and then we'll head on to the final forecasting challenge. Okay. All good there, Sorry. Yeah. Sorry. If what is not possible? Okay. Only I think there are a lot of PCs which had issues. We are planning to change the menu. You can use today, it's just Excel. Yeah. As far as you can access my learning, then today you don't need Excel. Okay, so everyone, let's get started. I need your full attention. Excuse me. I need your full attention. And please, while I'm giving the instructions, if you keep on talking, then I have to raise my voice to neutralize yours. You're still talking for me. It is really a pressure on the throat. So please be considerate. And when I'm talking, at least you can be quiet. Then whenever you find an opportunity, you can always talk. Okay, let's get started. I want 100% attention here. You're not doing anything on your screen. You will get your opportunity. You will be given data. You will do it on your own. But as of now, just focus here and answer the questions step by step. Okay. I'm starting with something on the screen where you see day as one of the columns, day 1, day 2, day 3, day 4, all the way till day number 8. I'm going to put up some sales data. Don't curse me for it because you would never see such amazing sales data, but good to start our discussions around that. And I'm taking you from the fundamentals all the way till the expertise level when we think about regression. So here is the data in front of you. There is a company which is recording sales data. And as I said, in a realistic world, you'll never find 2, 4, 6, 8 kind of data. But let's assume that's the case. Let's also assume that nothing else in the world is affecting sales. It's only day and sales. There's no other variable which is impacting your sales in this firm. A very simple question to begin with. If you have to predict what is the sales for day number 9, what would your answer be? Very simple. Welcome. You already know regression, you already know forecasting. So that's a great start. Let me complicate a bit. What do you think is the predicted sales for day number 31? 62. How did you get that? Multiple of 2. All right. Now let's slowly build it from there. Let's assume the day is represented as X and sales is represented as Y. Did you draw a relationship between X and Y? What was that relationship? Y is 2 times of X, right? Which means put any value of X, double it, you will get the value of Y. Welcome to regression. This is exactly what regression does. It looks at your data, it learns from your data, it tells you a relationship between X and Y, or if there are multiple X1, X2, X3, X4, and Y, whatever. In this case, there is only one X and one Y. So it understood the relationship between X and Y, and you were able to do it yourself. That means at this point of time, you do not need regression. Mentally, you are able to assume and see the relationship. Few more questions. This activity which we did right now, where I gave you the data, you gave me the relationship, and you said y is 2 times x. Will you call this pure AI or is this machine learning? Machine learning, 100%. Can you tell me why? This is not pure AI. Why? What? How do I confidently say this is machine learning?
There's a formula.
There is a formula, but then, yeah, that is a valid argument. More importantly, if you connect back to last week or last week's session, what I told you, there is one difference between machine learning and pure AI. Pure AI works with intuition, if else, if else, if else. Machine learning works with data, historical data, and you actually, all of you, what you did right now, you assumed the role of a machine. You learned from the historical data and you came up with a relationship and you found the relationship and you said, look, y is 2 times x, put any value of x and get any value of y. Okay. In fact, what you actually did is machine learning. Next question. When I asked you what's the predicted sales for day number 31, you said 62. This activity, is it supervised learning or is it unsupervised learning? Why supervised? There is only one variable that you are interested in. What were you interested in predicting? Sales. That's it. Every other variable, which is day number or if there were other variables, they are all helping me predict that one variable of choice, which is sales. And that's why it is a classic case of supervised learning. Great response so far. When you came up with the equation, just focus now, and then you'll get a chance to do. When you gave me the equation, which is y equal to 2x, what do you think is the independent variable and which one is dependent variable? X is independent and y is dependent, right? It's pretty straightforward. Why do we say that? You can put any value of x, which means x is independent. X can take any value. X can be 1, x can be 30, x can be 40, does not matter. But depending on what value of x takes, y will be 2 times of x, right? This is all fundamentals of regression. In fact, regression helps you get that equation, understand the relationship. Right now, you did not require the help of regression because mentally, it was good enough. You could assume, you could see the relationship, and you could come out with an equation. So far, so good. Machine learning, supervised learning, because there is one variable that you are predicting, and the result of the learning is in the form of an equation that can connect x and y. All right. Shall we complicate this data a bit and see if you're still able to do it? Okay. Now what I'm going to do is this. Okay. Now listen to my question. Let's see who is the smart one here. Can you tell me the predicted sales for day number 30? 63. Interesting. Anyone else? He says 63 without dragging or doing anything on himself.
Take the question which number?
Day number 30. What is the predicted sale? 63. Tell us, Aisha, how 63?
Because it's more 2x plus 3.
Wonderful. I usually get that quite late, and people generally fail to get the relationship between x and y, but that's a great job. Y is 2 times x plus 3 is the underlying relationship. Check it out. So 2 times 1 plus 3 is 5. 2 times 2, 4 plus 3 is 7. 2 times 7, 14 plus 3 is 17. So if you just do 2x plus 3, that's the relationship between x and y. And I asked you for day number 30, which means 2 times 30, which is 60 plus 3. Good job, both of you. Fantastic answer. 63 is the key. But you saw what happened right now. In the earlier case, everyone jumped with an answer, and when it was only double, when slightly things became a bit more complicated, then it was difficult to formulate the relationship between x and y. Let's make it more difficult. And now let's check what's happening. Okay, now forget about day number 30. Just tell me what the predicted value for day number 9. I've just changed the data, and this is more realistic. 2, 4, 6, 8, 5, 7, 9 will never be a realistic sales data.
34.
34. Okay, any other guess?
35.
34, 35. Okay, let's store all these answers because I also don't know what the answer is. We'll have to do it.
37.
37. All right.
45.
2x plus.
But the ninth day,
Yeah, no, I mean, were you able to find the general equation first of all? What is that equation?
it's like for every day it's different.
That's the problem. And that means if I can't have a generic equation, how do I put the value of x and how do I get y?
There's no
But
equation.
there will be, that's where we come coming to. But let's take more guess, any guess from this side, take a guess now. What do you think will be for the 9th day? We'll do it. What is the most likely prediction for day number 9? Any guess, throw any numbers, whatever comes from your observation of the pattern. Yes? Any number? Any number, Harsh? Can it be 24?
35 or 30.
35 or 32? Yeah, at least what I like is whatever guess you are taking, you are still following a pattern. You are seeing the numbers are increasing as the day increases. So, very less chance that suddenly it will reverse until and unless there is some external variable. And we already mentioned there are no other variables which are impacting sales. Now, everyone pay attention because this is where we are starting regression. Now, if it was humanly possible to find out the relationship between X and Y, you don't need algorithms, right? And this is exactly where machines come in. And this is exactly where algorithms come in. Now, the machines and algorithms are coming in and they are telling you, we will find out the relationship between X and Y. There are various ways of finding relationship. One of the fundamental algorithms which finds the relationship between your independent and dependent variables is called regression, which is exactly what we are going to see today. I will show you on how fundamental this regression algorithm has become that pretty much now every tool, every single tool that you work on today has regression stored. And it has become so basic that you will understand where all regression is actually done, but you never realize that at the back end there was a regression which is happening, and we will reveal as and when we go forward. But let's first understand what is regression, what are the steps to do regression in Excel, and then fundamentally develop that understanding for our first algorithm so that we can do the subsequent algorithms much more easily. Shall we get started? Okay. All right. Now, when you have to find or do regression, there are certain steps involved. And you need to follow these steps. Right now, don't do it. Just observe what I'm doing. I will give you a data where you can repeat all these steps and you can tell me the predicted value. But as of now, just observe what is happening, what is the process, what is the trend line, what is R square. We will discuss some mathematical parameters, but those will be very, very interesting. It will help you understand how math actually works. Shall we get started? All right. So step number 1, which you should always follow, is select your data and visualize your data. See the trend of how your data is behaving. Now, in order to visualize, I'll click on insert, and probably the best plot here is scatter plot and scatter with smooth lines. I repeat, I select my data, step 1, visualize the data, go to scatter plot, select scatter with lines. Now, before getting into regression or before getting into the algorithm, there's a manual step important, and I'll prove it to you later. Okay, this manual step is so important. And what is that manual step? Before formula. So before formula, the manual step is, as an individual, I will look at this graph and comment in my head, what is the relationship between X and Y? In the sense, What do I observe? What happens to y when x is increasing? Tell us. That's correct. So is it increasing trend? Is it decreasing trend? Is it a linearly increasing trend, linearly decreasing trend, etc., etc.? We start taking notes. Okay. Look at this graph. What do you think happens to y in general when you increase x? Does y decrease over the period of time? It is increasing. As x increases, y is also increasing. These are all mental notes. I'm just taking my notes so that I'm able to interpret the equation and the relationship much more accurately. So in my mind, I look at this graph and I say there are variations, but in general, as x increases, y also increases. Notes close. Step number 2. This is the time when I will ask Excel to run regression as an algorithm. Remember, you can run these algorithms anywhere. In Excel, the only algorithm of AI that you can run is regression. But regression can also be run in Python, in DataIQ, in Stata, and all the other tools that you would see, because it is one of the most fundamental algorithms that you will see anywhere. Of course, in Excel, you can't go beyond it. For example, logistic regression, decision tree, and all that, you can't run. That's why we need advanced AI tools. But right now, I go to step number 2. I will ask Excel to run regression. Let me show you how to run regression. Now, what I will do is I will right click exactly on the curve, and there is an option called add trend line. Has anyone seen this before? Yeah. Now you click on add trend line. Okay. And I scroll down all the way, and there is display equation on chart and display R square value on chart. Just hold on here. I'll explain everything. Now, that's all what I wanted, right? I wanted a relationship between X and Y. But before that, let's question some of the things here. Please don't do it. As I said, you will get an opportunity to do. Understand this first. As soon as I asked Excel to add a trend line, what did you notice that got added on the graph? Dot, sort of a line, which is there on the graph. Now, here's the question to you. Can you explain it to a layman? What is that dotted line? No mathematical terms you can use. You can't use any mathematical terms, but still you have to explain it to a layman. How do I explain where did that dotted line come from? Can anyone attempt? Think. No maths. Simple English. Can anyone explain? Yes.
How accurately solve the formula.
Okay.
That is the answer we might get. So
Interesting.
from the actual line.
Interesting. I'll reserve that answer. Partially right, but partially something needs to be clarified. Anyone else would love to see some views? How would you explain this dotted line to a layman? Someone is asking, where did this line come from? What is this line? Dotted line. Yes? You're explaining something, put it in words. You can try. Louder. Give it a shot, no problem.
It's like from the starting point to the end point.
From a line from start point to the end point, but there would be many routes to it.
What happens, right?
Yeah. Okay. All right. Interesting thing. Anyone else?
Can it be the prediction to the original paper?
Prediction to the, but see, the prediction can only happen if I increase the days, like for 10, 11, 12. And for that, there is nothing. It is on the existing data. Good thinking. That is in the prediction. It's not the prediction because it is for the exact given number of days.
So it's basically a guess.
That's very close. That's very close. I'll also listen to online. Yes, sorry, tell us.
I'm saying that it's basically a guess. They're trying to guess based on this line.
Interesting.
Yeah.
Okay, thank you. Can you repeat your answer? Yeah. interesting. So she says, so she says that a dotted line would sort of represent a perfect relationship if at all it existed between X and Y, which is also very, very close to the actual answer. Now, let me tell you what is that dotted line from a non-mathematical perspective first, and then I will tell you.
Growth of sales.
Sorry?
Growth of sales.
Growth or trend of sales, which is also very close, right? Now, let me tell you how to think of this dotted line. Now, this dotted line is the closest line possible ever to your actual data. Let me repeat. The dotted line is the closest line ever possible to your actual data. Now, what do I mean by closest line? Do you see some gaps between the dot line and the actual line? There is a gap here, there is a gap here, there is a gap here, there is some gap here, there is some gap over there. If you add all the gaps, this is the minimum possible gap ever that can happen to your actual data, which means transforming again to a layman's language. There is no other dotted line in the world which can come more closer to your actual data, which sort of matches all your answers. So you said perfect relationship between X and Y. If at all there was a perfect relationship, it would look like this. It shows the trend on how X and Y behave as they go. All your answers are correct. But technically speaking, in a layman's language, it is the closest line ever possible to your actual data. Now, if you go to the math of regression, which I don't want you to go, you're not doing PhD, but you can actually think how the math of this would work. If you add all the gaps, okay, and if you see the gaps, basically, I don't know if you remember your +1 and +2 mathematical textbook. If there are 2 points, x1, y1, and x2, y2, and then the distance between the 2 points is y2 minus y1 whole square plus x2 minus x1 whole square. That was the Euclidean distance, if we remember long, long back. This is that. All the Euclidean distances are added up and minimized so that the gap is as close as possible. But we are not bothered about the math. What we need to know is this is the best fit line. This is the closest line for your actual data, and there is no other dotted line in the world which can get more closer to your actual data. And once regression finds that line, it gives you the equation of the line. Once you get the equation of the line, problem solved, put any value of x, get any value of y. Let's do that first. Let's see what the prediction is. So to see your guess. So I have the equation with me. For which day were we predicting? Day 9. So I would say equal to 3.8214 times x, which is 9, plus 0.4286. 34.82. So someone said 34 actually. Yeah, so very close. 34, 35 is the predicted value for day number 9. Few more things before you start experimenting. There is one more parameter on your screen, which we haven't discussed. R square value, which is 0.9831. Here is an opportunity for you, especially those who have taken the other module. Can you explain how do I tell a layman what is that 0.983? What is R square? Is it good? Is it bad? How do I interpret 0.9? Interesting. Actually, it's the opposite of that.
How accurate?
Sort of how accurate this is. But remember, we do not use the word accuracy for R square. Now that you know what the dotted line is, you should be able to tell me what is that R square is.
Difference between the actual data.
That's correct. That's correct. Now let me explain. When you say R square is 0.98, you know what you're actually saying? The dotted line is 98% closer to the actual line. And do you think this is good or bad? 100% good. No, it's just 2% difference, and it's a great trend line to believe that your equation is correct. Now, let me tell you the biggest problem in AI, the biggest problem in history is people ignoring mathematics. And let me tell you where you will fail. There will be a chance when you run regression, the algorithm will never say that this is a horrible prediction. The algorithm will never say, sorry, the data is so bad that I cannot put an equation. Whatever data you give, it will give an equation and it will say X and Y are related like this. And you would say, wow, I got the equation, put the value of X, do the predictions and go on. And on many occasions, people ignore R square. Now imagine if the R square is 0.5, it will still give an equation, something X plus something Y. But it also is telling you that R square is 0.5. Can you tell me what does that mean? 50% difference between trend line and the actual data. And now you as an analyst will question that. You would say R square is only 0.5. Do I trust that equation? Never. I would never take an equation where R square is 0.5. But remember, in all the tools, it will run it. It will never say it's a bad algorithm or it's a bad fit and I cannot plot the equation. It will give you the equation. It will also give you R square. And if you don't understand what R square is, you would say, oh, I got the equation, put the value of X and get the value of Y. In fact, I want you to see R square in action right now. Okay. See what happens when I change the data points. Let's say instead of 19, here there was 38. Look at what happened to R square. It went down 0.69, which means only 70% closeness between trend line and actual data. Let's disturb more data points. Let's make it 21. Let's make it 35. Have a look. In all the cases, it is still giving you the equation. And that's the problem of AI. It never says it is wrong or I cannot run it. Whatever crap data you give, it will run it. It will give you the equation. Now, a person who knows math will say, look at the R square in this case. It is 0.03, which means only a 3% fit between trend line and the actual data. In your worst of the nightmare, you would never consider this as a legitimate equation. So I would disregard it. But someone who doesn't know R square would say, oh, I got the equation between X and Y, put the value of X and get the value of Y, which is why that is very, very important. Next, let me tell you in which cases were you able to solve on your own. You remember the first data? What was the first data? 2, 4, 6, 8, 10, right? Now see what happens to R square. So when I do 2, 4, 6, sorry, and our original data was this. What happened to R square? 1, which means 100% fit between trend line and the actual data. And that's why you don't see the trend line. The dotted line is actually on top of the actual data, which means there is a 100% match between trend line and your actual data. In such cases, human mind is capable of getting the equation. So you are able to say y equal to 2x. Let's try for the other one where you gave the equation 2x plus 3. Let's try that. So if it is 5, 7, let's make that data. There you go. Again, R square is 1. Perfect. R square, perfect trend line, perfect data, perfect equation 2x plus 3. So wherever R square is 1, which means the actual trend matches what is there in data, human mind will be able to come up with the equation. You don't really need regression, but in any other case where the trend line starts deviating from the actual data, that's when you need regression, and that's where we deploy this algorithm to find the relationship between X and Y, to observe the R square. Don't ignore the R square. If R square is bad, yeah, I will do it, but I will not use it for predictions. I will say this is a bad equation. And as and when we progress in today's session, you will see there are ways to deal with a bad R square. If you get a bad R square, it does not mean that I'll stop doing. You explore few other ways by which can I make a better R square and accordingly change the equation, accordingly use it for predictions and forecasts. Okay. Ready to try one small data set on your own? Let's go for it. So let's download the data first. So in week 4 folder, you will find an Excel sheet called basic data, the first one. Basic data.xlsx, not long data, not data, basic underscore data. That's the file I want you to open. Everyone has access to this data? Yeah. Same
Yes,
case,
sir.
there are some days, day number 1 to 30. There is some sales. Your question is very simple. Give me the predicted value for day number 14. Let's get started. Follow the steps. Select your data, go to insert, go to scatter plot with smooth lines. Make the graph first, observe the graph, then right click, add trend line, right click exactly on the curve. 32.9. Okay. Others, select your data, only the numbers all the way from 1 to 31. And go to insert. I can show you the options so that you don't get confused. Scatter plot and the second one, which is scatter with smooth lines and markers.
So, on right, hello.
Go ahead, please.
Yeah, so when I clicked, right clicked, I cannot see add trend line
Yeah, that's because you're not doing right click exactly on the curve.
on the, okay, okay.
Yeah, just right click exactly on the curve and you'll find add trend line. Anyone else? Or any other prediction? See, 32.9. Okay. And what's the R square? That
0.99.
so 99%, which is good. Okay. Others keep trying, then we'll do it together, and then I'll show you a surprise. Sorry. No, the first data, basically. In the data. Middle? While learning, okay.
Yes.
This side, 32.9.
Yeah.
Lights. All good? That's correct. That's I'm coming to that. So, at 29, you will do that. Just like 9 and 9, plus the man will be all good? Okay, everyone, for the interest of all, I will do step by step again. In case you missed it, please do it with me. So, yeah. All good? You have the data with you? fine. Just give me a minute, I'll check. It's okay, calm down. All right, so let's do this step by step. Let's select the entire data. And tell me the next step. What should I do? Insert, yes. Scatter plot. Scatter with smooth lines. Okay. Now, everyone, please pay attention. I'm not sure if all of you followed the mental notes. Do you think this graph is potentially any different from a mental notes point of view compared to the previous one, or is the same? Almost the same. As x increases, correct. As x increases, y also increases. So fairly, I'm looking at a linear sort of distribution. Now I right click and add trend line. And I click display equation on chart, display R square value on chart, and that's the one that I want. Okay, now everyone be careful here. Few things that you need to notice. Number one, I would first check R square and then I would check the equation. Okay. I would first check, does this whole exercise make sense? What is the R square here? 0.9948. And I will repeat, this means the closeness between the trend line and the actual data is how much? 99%. Good news or bad news? Good news. Also, I can trust, very easily I can trust, I can use that equation for doing forecasting, which means I can put the value of X and get the value of Y. What's the value of X that I'm trying to put? For which day am I trying to predict? 14. All right. So what I can do is use any space in the sheet. I can put an equal to sign 2.1209 times 14, which is X, plus 3.2308. And that would give 32.92. That's method number 2, which I'm coming to. Yes. Now everyone pay attention. Has anyone not got this so far? Let me know. Want me to repeat? All good? Okay. Now please listen very, very carefully. This is exactly what I want you to understand from tools perspective. Aisha, just 1 minute. Need any help there? Okay. Now have a look on another way to do this. So everyone pay attention. Now you say, well, I invested a lot of time. I did a graph first. I did mental notes of that. I said as X increases, Y increases. Then I did trend line. Then I did equation on chart. Then I did R square value. Put the value of X and got the value of Y. So there was a series of steps involved in this whole process. Probably takes you 10 minutes to get everything done. Now someone else comes in and says, why are you doing all this graph? Regression is such a fundamental algorithm that all the tools are anyway using it by default. I say, what do you mean? And this is exactly the answer. You don't need all this. You don't need graph. You don't need equation. You don't need to put the value of X. All what you need to do forecasting is this. Have a look. Just select your data and just drag it one down. You get exactly the same answer, 32.92. And imagine how much advanced Excel also has become, that when you drag at the back end, it is doing regression automatically. It is putting the value of X as 14 and it's giving you all the results that you need. And now there is a big question mark. There is a big question mark. Why do you need to know the longer method if dragging can give you the answer?
Because to make
It's
it
okay.
the
Sorry.
credit for a lot of values.
That's one. That's good. So let's say if you want to predict it for day number 5,000, right? So then the only way right now is you just keep on dragging all the way till 5,000 and get the answer. So that way, yes, I agree. Definitely for larger values of X, then formula is always something which is important. But I want to prove today that even for smaller values of X, what happens when you don't break the black box? And what do I mean? You don't break the black box, which means you don't understand the math, you don't understand the formula, you don't understand R square, and you say, well, I can just drag and get the answer. Why do I need to know all this drama? Is what I'm going to prove in the next exercise. Shall we do one more forecasting thing? Pretty much similar, slightly different data. Okay, let's do this. And for the next one, I want you to try both the methods. I want you to first try with the original method, which means do the graph, get the trend line, get the equation, put the value of X, get the value of Y, and then also try the dragging method and see in which case what difference does it make? Only some decimal values or bigger difference? You need to tell me. Now, where do you find this data? In the same week 4 folder, there is longdata.xlsx. Long data is the one that you'll be downloading. And let's open this and let me tell you what you're doing in this data set. Is everyone ready with the data? Okay, here is your task. You have 24 days of data. I want you to good ringtone. Oh, that was a game. I thought that, yeah, the ring. You were playing a game or was it? All right. So you have 24 days of data and you want to predict or you have to predict for 25th day by both the methods. Dragging method and the other method. Okay. Can I see that? Okay. That's pretty quick. By both the methods. Try both and find the difference. How much of a difference does it cause in both the methods? Something is wrong. Why did 34 only for the next? So it's given only till 24. Only till 24. Yeah. Sorry. What's the number? 18. 1897. Equation. That much of a difference. No, there's only one. Yeah, then it's fine. Right. Yeah.
Except cost and conditions.
That, what is the difference that you're getting in both methods?
0.962 and 970.
Minor difference. Minor difference. Okay. Again, we'll do this together, but figure out for another 5 minutes. How much? Sorry. Only for 23. You need to correct. I got the equation, yes. Yeah, only for 23 will take. Yes. So probably just make a new. Make a new sheet and copy this. The one where you were getting the graph. Just take out. That 180.
I did this one first, and then I did the second remaining blank one.
Okay.
The difference, 0.36 was the normal,
Okay.
and then after I added the right method, it came to 0.477.
So minor difference in decimal. Just wait for 2 more minutes and then we just surprise. Hey, money, zero times. All right, so now I want 100% attention, everyone. Please have a look here. Last row, don't discuss because whatever you're doing is absolutely wrong.
What?
Yeah, so that's why don't tell your friends what it is because whatever anyone has done so far is absolutely brutally wrong. And I just told you in exercise 1, I told you that I will prove it to you that dragging method is, it's just like staying out of the black box. You need to break the black box. And the unfortunate part is, all of you knew how to break the black box. We just understood what is a trend line. We understood what is R square. Conveniently, I think everyone forgot R square. What was the R square in this case? 0.43, less than 50%. Less than 50% means I can actually toss a coin. The probability of heads is still 50%, right? So this is almost like you're tossing a coin and you're saying, that's my prediction. It could be this, it could be that. R square is less than 50 percentage, which means 50 percentage of your trend line does not match your actual data. And if it does not match your actual data, how on earth could you believe that the equation is correct? And why did you put the value of x and get the value of y? But forget about all that. Even coming to that part is quite late. Let me tell you a bigger blunder that many of you did, and possibly the blunder that analysts always do is not even reading out the numbers. When I asked you what's the predicted value, no one gave me in words. Everyone was saying 1809, blah, blah, blah. What is that? 18,000, 189,000. What does that mean? And the moment you read, you'll understand already you're doing a big blunder. Let me explain with the dragging method first. Let's do this together. So let's do the dragging method first. Everyone, pay attention. So I have done this. I drag a step down, and very conveniently, everyone said 18097. Great. But have a look at the previous sales data. You started with 10,000 in day 21, then 17,000, then 28,000, then 46,000, and all of a sudden now you're saying the prediction is 17,000, and nothing else has affected sales. There was a clear growth trend and an astronomical growth trend towards the last 10 data points, and suddenly your prediction says 18,000. That itself shows there is a big problem in this. I cannot trust this dragging, and this is the problem with dragging, because at least now you have an alternate method. You can do a trend line, you can see what is R square, but if you don't know anything and if you believe the tools that do the job for you, this is how the tools do the job for you. They assume certain things, they do the dragging, and you would say 18,000, you would report it to your manager, you'll get fired the next day. There has to be some logic, right? 18,000 after 46,000 makes no sense in the trend of predictions, which means time to go back to our method. But the problem is, even with our method, you reported the same 18,000 something. That's because you conveniently ignored R square. And this is a very, very important next 5-10 minutes to understand how to work with data. So let me remove this as of now. Let's go by the conventional method. I select my entire data. I go to insert, scatter plot, scatter with smooth lines. And what I'm going to do is pause for a moment. And this is a big mistake that everyone does. I know what you would have done. Directly right click, add trend line, go formula, do R squared, done. Because you are in a hurry to complete the task. I told you there was a step before adding trend line. What was that step? Checking for the trend manually. And this is where we ignore human intervention. This is where we ignore our observation on data. Now, listen to this very carefully. This graph on your screen is not the same as the ones we have seen previously. The previous graphs were very simple. As x increases, y also increases. Probably you are looking at a linearly increasing relationship between x and y. I look at this graph and I start commenting, and listen to my comments carefully. As x increases, y does not increase so much up to a certain point of time, beyond which the growth of y starts happening exponentially higher as the value of x increases. And this kind of a narration is not what linear is. Linear is very simple. As x is increasing, y is increasing. This is complicated. This is saying that y remains sort of saturated till some point, and beyond the certain value of x, it starts increasing exponentially, which means the first thing that you need to understand, you are not looking at a linearly distributed data. And in the real world data, this could happen. You might not always get linear data. You get all different types of distribution. And this is where manual intervention is so important. You look at the data and say, this is a different game altogether. It's not my typical y is something x plus something and I see the r square. So I need to be careful before I do my predictions. So let's get on. Now I move on to the next step, which is right click, add trend line. And let me put display equation on chart, display r square value on chart. And let me bring this here. And if you click on the dotted line, you will get the options again. Okay. Now, step one, before looking into the equation, I look at r square. And I would say, not that. Yes. 0.46, I would never consider. Till 8.85, 0.8, above 80% is a trustable trend line. Below 80%, I will be doubtful. Below 70, 60%, I will not even consider because there's so much difference between trend line and actual data. How do I trust the equation for any kind of predictions, any kind of forecasting? I would never ever do that. Okay, which means this equation is out of the picture straight away. I'm not going to use this equation for anything. Now, I keep my eyes on the default option, which I assume the data is. You see these options on the right hand side? You see exponential, linear, logarithmic, polynomial. There are various distributions of data which exist. You assume that it is linear and you got a linear equation. But when I made my mental notes, I was very clear this is not a linear distribution. Can you take a guess? Which most likely exponential because you can see the nature of graph also. You can see how log behaves. It behaves like this, which means it initially increases and then saturates. You can see how polynomial behaves up and down. You can see how power. So power and exponential probably come the closest. But in this case, this is a clear case of exponential because in exponential, it grows very slowly and beyond a certain point of time, it goes higher and higher and higher. And that's when you know that, boss, I was not looking at a linear relationship. I was looking at exponential relationship. And this is the problem with tools. This is the problem with dragging. They wouldn't see anything else. They would say everything is linear, just drag it, do the equation, give you the prediction, and you have no other option than to trust that. So let's change from linear to exponential. Sorry. Yep, there you go. Okay, so everyone have a look here. This is what happens when I select exponential. Before looking into the equation, I would first check r square. In some case, I think you would have got 9.9999. In my case, it just rounded off to 1. It's not exact 100%. It is 99.9%, which means your trend line is now almost close to the actual data. And that's the one I will believe in, not the one that I got last time where r square was 0.46. Of course, the downside is the equation has become complicated. It is 0.4632 e to the power of 0.4791x. And that's the value of x that if I put as, for which day were we calculating? 25. So if I put the value of x as 25 over there, then I will get the actual value. Do you want me to put the value of x as 25? Let's see how to do a e function in Excel. So I'll just put an equal to sign over here. And I would say 0.43. Everyone, please have a look here. 0.4362. 4632. Thank you. Multiplied by. Now, e to the power of, which means I can use an exponential function, 0.4791 times x. X is 25. Yep, that should do. So basically e to the power of 2, if you want to calculate in Excel, you just type exp in bracket 2. That means e to the power of 2. So if you type exp in bracket this entire thing, that means it is e to the power of that. So what value do you get?
3,700.
That looks correct. That looks correct. It should be in 70,000 something because last value was 45 something, so it should grow. 70? Perfect. 73,710. I'll put the formula again. There you go. I have added an extra bracket that's not needed. You can just do multiply and exp brackets. Any questions? Anyone needs any help on this? Let me know. All good? Okay, now just pay attention before we go for the break, because after you come back from the break, we are ready for a forecasting challenge. Okay. Now let me tell you the problem with forecasting challenge. Now the doors have opened, which means now you will clearly know that, oh, let me check. So let's say when you started doing the equation, you did linear and r square came out to be 0.85. Okay. If I would not have told you this, you would have stopped. Sorry, yeah. If I would not have told you this, you would have stopped over there. You would have said, oh, linear is good. I got 0.85 as r square. You would have got put the value of x and got the value of y. But now the problems have actually increased because you know I can check other options. Is it polynomial? Is it logarithmic? Is it something else? And especially when you are not able to make up your mind on what it is, you want to try everything, right? And now there are multiple angles of decision making involved. Number one, which distribution do you choose? Number two, do you choose on the basis of distribution, or would you rather see in which case r square is becoming better? Or do you visually see in which case the trend line is becoming closer to the actual data? All options will suddenly increase.
So, but when we drag the data, so like is Excel defaultly goes for the linear?
100% correct. Always it assumes that every data will be linear data, and it doesn't do anything beyond this, and that's the problem. Unless we know that there's now I know there's an assumption linear, so I'll be careful while dragging. But if I don't know, I will say, oh, that's the predicted value, and I'll go with that. So great observation in Excel. When you drag, by default it assumes linear. Now coming back to the forecasting challenge. I will be giving you data, something similar, but the problem is everything looks correct. Now, when you think this is linear, you might say, oh, this actually looks like linear. Then when you try log, you would say this also looks correct. Then when you try polynomial, you say, no, this also looks fit. Now, when everything looks correct, it has multiple r square values. All r square values are also good. Nothing is extremely bad. So nothing comes out like 0.3 or 0.4. When all the r square values are good, when everything looks correct, when nothing comes as a decision making, what would you decide? That is a big challenge. And in the forecasting challenge, every individual can choose only one answer. You cannot say, if it is linear, the predicted value is this. If it is polynomial, the predicted, no, nothing of that sort. In fact, you can even rely on dragging, and you can say, I believe the dragging answer is correct. Whatever method suits, whatever distribution suits, you have to come up with one final forecasted value. However, it's not as easy as it sounds. In the sense, there are few hidden elements. And again, it's an analyst mindset that you need. You need to look at the graph. You need to look at why this is happening. What is this? Can I check this? Can I do that? Can I try this? Observe all the R square value. Do whatever you can in the world, but come up with one final answer. You say, as an analyst, my prediction for the 27th day is this. And you fill in a form where you say for which day you're predicting, what's the value, what's the predicted value, which distribution you chose, and you submit your answer. And once we come back next week, I'll announce the winners. And there is a massive hidden trick in that exercise. It's not as straightforward as just look at everything and find the best. You really need to apply your mind. You can choose any resources in the world that you want. If you want to take help from GPT, go ahead, plug in data. You can do whatever you want. Try anything, everything, come up with one final answer. Are you all ready for the forecasting challenge? Yeah. All right. So let's take a break now. 2:45. We come back sharp at 3. Please come back on time because we'll distribute the data and then start the challenge. Thank you.
Hello, sir.
Yes.
Yes, I wanted to ask you regarding the summative assessment.
Mhm.
I just wanted to ask, there is no deadline mentioned in the module handbook.
Correct. That's because the hackathon will be somewhere around week 7 or 8, week
Okay.
7 most likely. And the final 60% submission is after the end of the module.
And after the end of the module, that would
After the
be
end
in
of the module.
August, I believe.
Or July end or August 1st. Yeah.
Okay. And I had another question. Uh, no, where can I find the assessment brief or anything like that?
We will be distributing that. So once we talk about each assessment in detail, you will have a
Yes.
PDF document, you will have a marking criteria, everything.
Okay, just one more question.
Yes.
I have checked my my MDX calendar, and it's showing that on July 5th there's a PPT submission of applied artificial intelligence module.
No. Where did you see that?
I can show it to you. I have a screenshot.
No, that's
Just one.
for the previous reset. That's not for this one.
Okay,
Yeah.
okay,
So
okay.
you'll be
All
informed
right.
of all the deadlines. Everything will be in written. Don't worry about assessment.
All right. Okay.
Okay.
Thank you so
Perfect.
much,
Yeah.
sir.
No problem. Yeah, I can. So for the next one, I can. All right, shall we get started, everyone? Okay, so what do you need for the prediction challenge is in week 4 folder on my learning, you will see data, only data, not basic data, not long data. Just download data.xlsx and open it, and I'll explain what is there inside the data set. And then I will make you go through the form that you have to fill in so that all the Q&A is discussed. And then I'll give you a timer, and then you will start your prediction challenge. Has everyone downloaded this? I want you to first see main data and then I'll explain the other ones. 2 more minutes, yeah. Yeah, you'll see 3 sheets. So the file that you downloaded, you will see 3 sheets. One is weak pivot and one is final prediction and one is main data. I want you to stay at main data right now, which is where we start the explanation. And then I'll tell you what is there in all the sheets and what are you ultimately trying to do. Let me know if anyone wants me to wait for all of you have downloaded? Yeah? All right. So let's get started. Number 1, you have your main data, which is basically a company recording their sales volume on every single day. Okay. So there is a date given, there is a sales given, there is another date given, there is a sales given, blah, 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 blah. Okay. Now, can you tell me what is the difference between this kind of data for prediction versus what you have already seen? This is date is there. So let's say at this point of time, if you want to do the prediction, quickly, please. Yes. So in the week 4 folder, you will see data.excel, only data. Just download that and make sure you're at this screen with us. Data, only data. And there are 3 sheets, that's 5. You should be ready with the main data. Good. Okay, now everyone, pay attention once again. So in this case, the only difference that you see is instead of day 1, day 2, day 3, you actually have the dates with you. Otherwise, everything is the same. So at this stage, if you had to do a forecasting, the only thing you have to do is replace the dates with the day number. So instead of dates, you can start first day as day 1 and day 2, day 3, day 4, day 5. I don't know what the last day will be, and then start predicting it for the next day or subsequent days. However, here is a twist. Now, this company does not want a daily prediction to happen. Okay, they have daily data, but they don't want the prediction at a day level. They rather want it at a weekly level. Okay, which means week 1 there is some sales, week 2 there is some sales, week 3 there is some sales, so on and so forth. Whatever is the last week, the next week of that they want to do the prediction. Okay, now in order to convert the daily data into weekly sales, they have made another sheet called weekly pivot. And all of you can see that now. So the same data that you see in main data has been converted to weekly sales data. Exactly the same. The only thing is every 7 days they have added the total sales volume. So as you can see in week 1, the total sales is 102. In week 2, the total sales is 153. In week 3, the total sales is 164, so on and so forth. In order to make your life much more easier, they have replaced those groups of dates as week 1, week 2, week 3, and this is what you see in the final prediction. So you have week 1, you have week 2, you have week 3, all the way till the last week, and you also have your sales data. Now, once you arrive at something like this, then it's the same thing, right? Which means, see how many weeks are there. Can you check how many weeks are there? 26. Now, they want you to predict for the next week. Whatever the last week is there, they want you to predict for the next week. Now, again, pay attention. Don't start doing it because there are a lot of twists and turns. Number 1, imagine if this was the only sheet that you actually needed, I could have given you this directly, right? I could have just given week numbers and sales, and I could have told you go for weekly prediction. But I have given you daily data, I have given you the converted data, I have given you the refined data. Everything is there with you. Okay? That means there is a hint that even though this is sufficient to do forecasting, there might be some inputs needed from the other sheets as well to take some decisions. Okay, so keep that in mind. Don't directly say, oh, I've got final thing that I want. I can just drag and get the final answer. No, there is an investigative element involved here. You need to figure out what that is. You need to figure out, okay, how can I use these other 2 sheets, even though they all mean the same? Eventually, it's the sum of weekly sales, but there is a reason why you have been given the other 2 sheets also. They will be handy in your final decision. Okay. The ultimate aim still remains the same. Whatever is the last week, the next week of that, you need to do a forecasting. You need to give me one value, which you say is the final value. I don't know which one would you choose, linear, polynomial, whatever, exponential, log, use GPT, understand what it is, completely up to you. At the end, we want only one final prediction. Any questions before I show you the form that you're going to fill in? Any questions, any clarification on this? Daily data is given, converted to weekly data, refined in a much better way for you to do forecasting.
We have to use all the three data, just we can.
No, not necessary. So as I said, and as of now, everyone, please pay attention. One simple way is I can just drag this. It will still give me the answer for the next week, right? So you can get it without using additional data, but remember, if it has been given to you, it has to be some meaning. There has to be some reason why the other two sheets are given. And that's exactly, and I'm not saying use it, don't use it. It's just that there's a reason why it is given to you, and there is some investigation element required. Any other questions on the sheet before I show you the form? All good? Okay, now let's focus on where will you plug in the answers. And I want everyone to click the link, please. So if you go to important links, there is a link called Prediction Challenge. And if you click on Prediction Challenge, it will take you to a form like this. I'll share the link with you. So for the prediction challenge, this is what you have. Now go through all the questions with me so that there is no clarification needed. And if you have any questions, ask it right now. Number one, everyone, which distribution did you choose? Okay. So whatever final answer you are going to tell me, you would have chosen one of these distributions. Tell which distribution did you finally arrive at. Was it linear? Was it exponential? Was it polynomial? Blah, blah, blah. Question number two. What is your predicted value? So let's say the predicted sales is 400. So you put that actual number over there and you say the predicted value is 400. Which week are you predicting it for? Yeah, let's go back and check. 26 is already given. 27th is the week. However, now again, be very careful. And these are all small hints that I'm giving. Now up to you how you take the hints. If everyone was predicting for week 27, I wouldn't have asked this question. Which week are you predicting for? There is a question, which means there can be some deviation here. Now, let me repeat what the company has asked. The company has not asked to predict for week 27. That's not what they're telling. What they're telling, whatever weekly data you have, whatever is the last week, you predict the next week of that. Now I leave the thing to you. As of now, the last week is 26. You predict for 27. If 26 remains your last week, you predict for 27. If 27 by chance happens your last week, then predict for 28. Whatever is the last week in your weekly data, the next week of that you have to predict. And that's why you need to mention for which week are you predicting for. If things stand as it is, then for 27th you're predicting. If you do any changes, mention that change. Okay. Please enter the R square that you got for the equation which you use for predicting and the equation as well. What equation did you get? You put it. Any other comments? If you have, you can mention your name and your license. That's all what you have to plug in at the end. Any questions on the form? Come in. No questions? All clear? All the best. May the best predictor win. Let me put a timer. For the link. I'm coming. And your data is. You need help for the instructions. We can help you out. Let me know. So all three of you clean the instructions again, I can quickly get. Okay.
Yeah, it's the base.
This is the data.xlsx, okay, in B4. 20 minutes is what you have. Don't be in a rush. I know you would be tempted to just run it and say, oh, this is what it is, and that's the predicted value. But all the hints that I've given, make use of those hints. Question? That's a good start of it. That's just the start. Correct. Just one more thing which I forgot to tell. If by chance, everyone please pay attention because I know you'll be experimenting with this. So let's say you end up with an equation which is too complex. So let's say you choose polynomial of the order of 3 and things like that. The equation might be too long and you might not be comfortable putting the value of x. So what you can do when filling up the form, you can say that is the equation that you considered, but you were not able to put the value of x and get the value of y. If you are able to do it, you can ask GPT to do it, like copy the whole equation and say, can you calculate for value of x as 27? But by chance, if you're not able to calculate because of Excel capabilities, you can leave it over there and you can say, just refer to the equation where you can put the value of x as 27 or whatever x it is. You can do all the discussions with your friends or partners, but then the submission is individual. I want to do with that. How? Okay. For the forecasting, so the company has said, we are going to weekly data. The next week is next Friday. So we are giving company the predicted by, which is how sales will look like. Okay. Looks like we'll have to extend the time. Let's keep another 20 minutes. You're free to use any tool, GPT for any insights, whatever you want. Though it's not needed, but still. Yeah. Not necessarily. Like you feel is so if you only for example of your feel the best, then that's it mind the next one.
26 are.
Not necessarily. All this. Okay. Okay, so you have to complete the dates of that, okay, yeah, the rate, that's fine, and the day, later, so then, 5 days, okay. Okay. You have to choose one, fine. If you say, oil out is the best, then based on that, you will. Yeah, yeah. Again, that's your Let's see.
Still picking up.
Not necessary. You have to choose whatever you feel is the best. So all the options are open now. Everything looks good. So you have to choose one distribution which you feel is the perfect for this one. And based on that, you need to do the prediction. $16 more. That's why all the options are open.
So any hints for the week, which one?
All the hints.
Well, as per that only I can, not then the,
So, I mean, what exactly is the question?
the week one if you can like, just like which one. Not which one like, but
So the company says whatever list of weeks you have, the next week you have to predict. If you have 26 weeks predicted for 27, if you have 27 weeks predicted for 28. Yes, so if you are preparing for three, this will be 29. The best are to So and if you are not able to calculate, should you just ask for the so then put the value of then 28.
so I go with and then checking the creative value. We have to put some research and then check the highest. How do you
That's what I was supposed yeah. Figure out. Okay, yeah. One of the days, but I'm not confirming what is the rest, but definitely it makes sense. What you said makes sense.
No, really, that is option. For six, we don't have 31. 28 is in the
13 minutes more, and then I look at the answers, declare the winner, and then start the explanation. Yeah. It's an important things.
Five, 31 is not good. Check. That 31 is what we want. Yes, so next year is 29. Next year.
And calculated yourself. In Excel or? Yeah, you can submit the form. Because you will either manually calculate it in Excel or bring the whole equation and again ask, can I calculate for X equal to?
Just for you.
So you are calculating for X equal to 6, right? I can see some good solutions already. Let's see what will be the best one.
Sorry.
You can ignore it. In the comments, you can mention that you.
No, you want it.
6367.
On Tuesday, do you guys have any class in the morning? Any class? Because for the hackathon day, I need to find a common time between batch one and batch two. I'll check with the time. But Tuesday morning you have, it, right? Sorry, today is Wednesday. So Wednesday morning you have. Today morning you had a class?
No, sir.
Wednesday morning is everyone free?
No, sir.
Some students have, right?
Other group.
What about Thursday morning?
Have less.
Some, who have?
All the others.
No, the other batch, and you guys,
We can come in the morning also.
so Wednesday morning you are free? No, there's some.
11:30 we have class.
Yeah, some people they have class.
Which class?
Thursday morning, is everyone free? Thursday morning?
Friday.
Friday you are completely free. Okay. And what about Thursday morning? Because I don't.
Thursday, so we have one class.
When is that?
It's around 11:20.
11:30 you have.
So you want to combine the class, right?
Yeah, I got
Wednesday we have right now, and the first batch is morning, we can come in the morning, we can join them.
Wednesday morning, today morning. So
Yeah.
Wednesday morning, no one has. That's what they are saying.
Yeah.
Well, have a different
They
class.
have the.
Totally.
So then Friday will keep.
Friday.
Friday will keep. What? No, not this Friday. Some Friday, like we'll decide which. Oh, it's an every Friday. 10 to 12. No, 10 to 12. Yeah, so we can keep.
Don't even ask.
But then prayer will be there on Friday.
Now you.
But it happens every Friday?
Like for the next 3 weeks, every Friday,
Okay. Okay. And who takes that,
We can just start it. Just start it.
क्या चाहते हो?
I can take, depends on everyone, but Saturday, you have a graded exam, someone can take it. So Friday will find time, I'll ask them to sit the hackathon for one of the Fridays. Final 6 minutes. And then you discuss the solution by elimination. We'll see who stays in the competition till the end.
Right?
Correct. That. Which group was the winner of petrol station? I'm just putting all the prices here. Who were the batchmates? Sorry? Okay.
Petrol stations. We could. It's petrol station. What's this? I don't follow you.
Anyone still doing? If everyone has completed, we can start. Anyone who has not submitted? Okay. Last 3 minutes for anyone who is completing. Last 1 minute, if you have to be eligible for the prize. Oh, this is the one that you.
I'm not sure.
This is that is, it does not. Okay, time to discuss.
You should be self-aware. So that you want something.
Okay, everyone, let's discuss together. The way I haven't checked the backend, the way I will evaluate the backend is, at every stage of the discussion, some people will be going out of the competition. Which means if you haven't done this, you're out. If you haven't done this, you're out, etc. etc. The one who stays till the end, I will then check the backend if everything is what you're saying is there, and then we'll declare the winners. Okay, so let's get started with a very, very interesting exercise. And why I say it's interesting, because it's a sort of mix of everything, and that's what analysts do. They look at numbers, they look at the mathematical parameters, they look at all the possibilities of what can be done. And I was a bit happy when some of you were figuring out the issues and you said, oh, there is a problem over here and this and that. Which also many people miss. They straight away get to the forecasting and they don't realize there are potential problems in the data and how to deal with them. But I'm pretty happy. I think most of you had identified what the issue was and then you were discussing how to treat it and so on. So let's get started one by one. I will go for the final prediction data. Again, I would never rely on dragging to begin with. We all know the limitations of dragging. So what I will do first is go with the conventional method. Everything is already given. So I can do insert, scatter plot, scatter with smooth lines. Okay. Now, this is where the mental notes were very important. Okay. I told you you have to read out the graph and see what is there. So if anyone has to read out, can anyone tell me what is the general impression for this graph? Yes.
The trend is increasing.
Lubna, right? Yes. Tell me.
The trend is increasing, but at week 26 it suddenly drops.
Perfect. Now, in general, as X increases, Y is also increasing. There is no doubt in that. But then I do notice there is a sudden drop. Okay. And this is where the analyst would stop and say, look, I need to investigate what is happening here. If it is a genuine drop, then it's fine. I continue and I assume that that's the sales for the last week. But if it is a drop because of any error, then there are any issues. So raise your hands on how many figured out what the problem with that drop was.
I figured
Others?
it out.
Everyone figured out? You guys did? Yeah. Please raise hands if you figured out why that drop was problematic and why you should not consider that drop as it is. Can anyone tell me what is the problem? Dates. And this is why I told you there is a reason why that sheet 1 and sheet 2 and sheet 3 is given, so that you can go and check what is happening with your dates. So I go back to my main data and I say, okay, this is good. I go back to week data and I can see week 1 is 1 to 7. Week 2 is 8 to 14, which means every week is 7 days of data. But the moment I see the last week, it is 25, 26, 27, 28, and 29. It's only 5 days of data. Now, anyone who has not considered this is automatically out of the competition. Anyone who has not considered this, everyone has considered. Okay, so that's one drop, which means if you forgot that it's not a complete data set, then anything that you do from here on is problematic because you are assuming the last week is correct, but there is a problem. The last week is not correct. It has 2 missing days of data and you cannot compare the other weeks because other weeks are all 7 days of data. Now I need your help. What are the solutions? And I saw different approaches. Ali, can you tell us your solution, which is a fair solution? And I think you also did something similar. Tell us.
So I took polynomial.
No, how to handle this week first. We'll come to the distribution later.
So I just.
We'll
for this
calculate
week,
the
it
number
is
of days.
fifth of May 26, which had already been forecasted, so I just removed this week.
The entire week,
Entire
right? Okay. Online students, someone was trying to answer. Yes, you can.
Yeah, I was saying we will calculate the number of days and then divide it by 7 and figure out which week data is like accurate and which we need to find.
Interesting.
Basically, how many days are more.
Interesting. All right. Okay. Now, everyone, let me listen to all the approaches. Let me tell you the easiest approach is what Ali said, and there is no right or wrong here, but there is a way to think about what would have been the best approach. One of the easiest approach is I would say, look, the last week, which week number is that? 26. So I would say, look, the 26th week is problematic because there are only 5 days. Let's assume that the week 26 is not there at all, right? I have only 25 weeks of data and I will start predicting for 26 weeks. This is what the company wanted. Whatever you have as the number of weeks, the next week you should predict. However, while no one can say that this is a bad approach. No one will say this is not allowed. The argument that would come in, and this is where I want you to think and let me know if anyone has actually done that. The argument that comes in is this. A good analyst would say, look, I agree there are missing days, okay? But it's not 6 missing days out of 7. It is 2 missing days out of 7, which means you have 5 days of data, which is a potentially good information. And when you say you will remove the 26th week, in effect, what you're saying is, I knew the sales of 5 days, but I'm not considering that for the evaluation of the prediction, which means some known data which was in your hand, you're willing to let it go. I'm not saying it's wrong. So 100% it's an okay approach where you just let it go. But a good analyst would question that and say, look, we had 5 days of information. It's not that there were 6 days missing in the data that you ignore 1 day and you're good to go. 5 days is a good number and you only have 2 missing days of information. Now, this is what I want to ask. Anyone did anything else other than not considering the 26th week?
Yes, I did.
Figure out the rest of the missing days as well.
How?
But what I did was, instead of like skipping the other one, I did take the whole 6 months over data, but the last 35 days. and
Okay.
put it here,
Linear?
So I didn't consider the whole 6 months of the series because it was the early weeks didn't really matter to me.
Okay.
So that was not relevant for the sales. The last 35 days were the ones that were.
But what's the logic in early days not being relevant? That's also potential. Still, it's a potentially known data. And if you say early days I will not consider, it's the same thing as not considering the last week. Right? But a good approach, again, a different kind of approach. Anyone else? Go ahead. Which one?
Yes, because.
25, 26, 27, 28, 29. It's not there. Yeah. So then 4 days of data. That means 3 days of missing data. All right. Perfect. Good. Fine. I didn't see that. Good. Fine. So any other ways? Anyone has done anything else?
Yes.
So all of you have ignored the last week and one different approach over there. What was your approach?
Similar to one. So I calculated the remaining 3 days simply using linear and then.
Using linear what? Forecasting?
Yeah.
Forecasting, which means you actually did forecasting on a daily sales. All the days data. Yeah, which is a different approach. So because you said only the last one. Interesting. Now everyone pay attention. Now this is the kind of approach that is thinking in a good direction. Now what I would say is, look, I have 4 to 5 days, 4 days of data, right? And I have 3 missing days of data and one potentially good piece of information that I have, which we did not use so far, is the main data, the data itself over here. This is a daily level data. And if I just do a daily level forecasting, I can forecast for the remaining 3 days, wherever the data is missing, and then add those 3 days to the weekly sales and then complete that week in order to have the best utilization of the existing ones. However, no one is still out of the competition, because if you have ignored the last week, that's also correct. So not a one solution. If you have done averages, some people would say, let's take the average of all the weeks and plug in, let's take average of all days. Lot of different ways in which you can take that last week into consideration. Okay. Multiple methods. If all of you have used different methods, no. There's some echo over there. Sorry, online students, you're trying to say something? Oh, it's done mute. Okay. All right, coming back. Everyone, please pay attention. The story has just started. Now, as I said, multiple ways, whatever way you want to take forward, you can. Ideally, the daily sales data is available. You can forecast for the missing days. You forecast it by dragging, because this is sort of linear, or you choose the best way of forecasting. You can do another daily level forecasting, fill in for the 3 days, and then add it to the week, and then complete the week. If you complete the week, then you're predicting it for week 27. If you are assuming that 26 is not there, then you are predicting it for week 26. Okay. Now, the biggest surprise in the entire exercise, the biggest problem which I saw all of you getting into. Now, what I'm going to do is, let's assume I'll delete the last week. I'll go with Ali's method just for clarity now, to make it simple. So I would say, boss, I don't have 26th week here. I have only 25 weeks, and I'm going to predict it for 26th week. Okay. Now this is where the fun begins. Now I would say, all right, let's do the forecasting. Right click, add trend line. And let's see what the trend line says. Display equation on chart, display R square value on chart. And I'll just increase the font. Okay, now I started with linear. I looked at the trend line. I looked at the equation. I looked at the R square. And do you think this is a decent R square or problematic R square? Decent R square. 96 means it is 96% closer. Question. Did anyone stop over here and said, this is the final answer? How many chose linear at the end? 1, 2, 3. Why did you choose linear?
So linear, because I the first 25 weeks I took and predicted to 27.
Yeah, but again, the other options are better. That's what others did, right? I think you would have done polynomial, log, and everything.
I
Yeah?
taken linear and
Why?
exponential.
Both, but you have to choose one.
No, I just tried it linear
Try it with linear.
and exponential.
Okay. What was your reason of choosing linear? Did you try the other ones and then negate?
I did look into the other formulas, but the linear formulas in
Ah, okay. All right. Interesting. Okay. So actually, now this makes my job easy. No one has won it. No one has won the challenge. I thought amongst these three, I'll get the answer, the explanation, but not the explanation that I was looking for. Now, everyone pay attention. What am I talking about? So let's pay attention, Pavi. Now you would say, well, now that you know, there are other options possible. What are the other options? Polynomial, logarithmic, etc., etc. And the parameter that you were hunting for is, can the fit improve? Which means, can the dotted line become more closer? Which means, can R square become much better? And if R square becomes much better, there is no argument in the world that would say you should choose linear. If there is a better R square, there is a better fit, you would always choose whatever is the better option, right? Today, I'll show you the beauty of mathematics and I'll show you the beauty of analyst mindset. Let me do this quick. Now, I started getting greedy and I was like, no, 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 0.96 is not so great. I can make it 0.98, I can make it 0.9 because I can play with all the distributions. Okay. So let's have a look at the distributions. Let me click on this. Yeah, there you go. So let me try exponential first. Now I want your inputs on everything. I tried exponential. The R square became better or worse? Similar, but the distribution became worse. I can clearly see, a sort of different distribution for the main data and very different angle for my exponential data. So there is no possible great reason for me to choose exponential at all. Even if it is a similar R square, I would never choose exponential because I can see a clear difference in the trend. When I choose log, now things are slightly becoming okay, still very different because if you see log, it starts from here and then it saturates. It clearly does not match the trend. So I wouldn't choose log, even if the R square improves. R square did not improve also potentially. Now let me try polynomial. This is where the fun begins. Now, if you look at polynomial, and I want all of you to pay attention over here. Just refresh and so insert scatter plot. Let's choose polynomial and let's do display equation on chart. All right, everyone, pay attention. Now forget about polynomial of the order of 3, which I know many of you have selected as the final option. Let's first debate on polynomial of the order of 2. Okay. Now, tell me any reason not to select it. Has R square become better? 100% yes. See, look, 0.9958 and linear was 0.96. Has the fit become better of the trend line versus actual data? Absolutely yes. What is the reason for me not to select this?
Complexity of equation.
Does not matter. Just because, and that's why your answer, even though you are on the right track, I did not like because yes, you are right. The equation becomes complex, but that's complexity for us. Like I have to put the value of x and get the value of y, but potentially that cannot be the reason for saying I will not select this because the computation is easier in linear. That cannot be the case. If the line of it is better, if the R square is better, you would want to select that. Why would you not want to select it?
So because it
1 minute, 1 minute, 1 minute, yeah. Does not matter because even in linear you can have minus 2.34x plus 320.
So I think because it reduces the predictive reliability.
Why? R square is better, fit is better, it should increase the predictive reliability. Why would not I ever consider? Of course, I can even consider x to the power of 3, even better fit, even better than R square. But let's argue about this compared to linear. Is there any case looking at a polynomial, I would still prefer linear? Can I show you something? Everyone pay attention. Now let's see. This is where understanding of trend is so important and how overfitting and deception can happen in the world of analytics. Let me prove it to you today. So let's assume I'm happy with this equation. Okay, I'm saying R square is good. I've got the equation, the fit is better. I will trust this equation. I will put the value of x and get the value of y. I will do this live in front of you. So what I can do is, what was the number for which we are calculating? 26, right? So I'll put 26 here and I can zoom in a bit. And let me type the equation. The equation is minus, and let's do all brackets and everything correctly, minus 0.6279 times x square, which means 26 times 26 plus 39.151 times x, which is 26 again, plus 54.61. Okay, everyone, pay attention. So I typed in the entire equation. For the value of 26, I got a prediction of 648. Now compare this prediction with that previous long data when you got 18097. Okay, that was an absurd prediction because the previous value was 45,000 and suddenly you got 18,000. In this case, do you think it is an absurd prediction? No, it's fine, right? If you look at the previous value was 648, and if it gives you 648.076, pretty much you are in the game. It's not a horrible prediction. Again, hinting that what I'm doing is correct, which means R square is better, the fit is better, everything is good, the prediction is not absurd. But the problem is how do I explain this? My short-term vision of what the trend is actually doing. Let me tell you something very, very interesting, and this is how the analysts think. Now, when we took the linear equation of y equal to 2x, and we started our session with 2468, right? Now, if I tell you the value of x is 50, give me the prediction. What will be your prediction? 100, 2 times 50. If I tell you the value of x is 1000, what would be the value of y, predicted value? 2000, 2 times 1000, right? If I tell you the value of x is 10,000, what's the value of y? 20,000. All these predictions make sense, okay? That means in this case also, the prediction should make sense, which means if I change 26 to 27 to 28 to 100 to 200 to 300, I should get some normal values, which is according to the trends. Let's do that. Now I will change 26 to 27 and observe the change. 653. Absurd prediction or okay prediction? Okay prediction, no problem. I make it 30. Decent prediction. I make it 100. Minus 2,309 is negative. Negative value of sales is your prediction when you did x equal to 100. Now, why did this happen? And this is the most interesting case of overfitting in analytics. This is called deception. This is what when you focus on short-term trend. And why did this happen is no one actually went to Google or GPT and asked how does a polynomial of the order of 2 in general looks like. No one saw a general graph. Linear, we all know looks like this. Okay, whatever in the world, it grows like this. But did anyone check how does a graph of polynomial of the order of 2 look like? That's the one. He's showing that it goes up, then it goes down, and then it goes in negative, something like this. That's how a polynomial looks like. And now you say if a polynomial looks like this, why did we get such a good prediction? The reason why you got such a good prediction is your data was lying till here. And till this point of time, your trend line and the actual data was matching. No problem. 99.99% fit between actual data and the trend line. The problem is what happens when you stretch the actual data? What happens when you stretch the trend line? When you stretch the trend line, it approaches a maximum, starts reducing, goes beyond zero, and enters into a negative number. And that's not how my sales data is behaving. Yes, sales data can go down, but it can't be a negative, right? I can't how do I explain a negative sales? That can never happen. So that means what I am looking at a trend does not match how I think about sales. Yes, it could go up and down, but as far as it is positive, I can still understand. In general, this is where I said that mental notes is so important. When you saw the graph, it was almost clear. As X is increasing, Y is definitely increasing. There is no indicators that it's suddenly going down, it's exponentially increasing, getting saturated, starting saturation. There was no indication of that. It was a very clear case of a linear trend. As X is increasing, Y is increasing. This ended up in a trap where you got caught up with the short-term trend. You did not see the longer picture of when X increases, what happens to the actual prediction. And hence, in spite of a better R square, in spite of a better fit, polynomial is not the trend of your sales data. Log is not the trend of your sales data. That's not how your original node data is behaving. And only on the basis of node data behavior can you extrapolate a unknown behavior. Otherwise, you're getting negative sales. And see, we just reached 100. Didn't even go for higher values. With X as 100, if you report to your company that the sales is negative, okay, you'll be thrown out of the job. This is what has happened in this case. So linear, and probably there is one more distribution that comes close, but again, you have to actually verify whether the trend matches the data, and that's why searching that trend online is very important. If you say polynomial of the order of 3, go and search. How does it look like in general? If it looks like this, reject. This can never happen in a sales data, and that is the power of I would say the case of overfitting data and the case of analysts understanding that overfit and not falling into the trap of higher R squares. That's not the only parameter. So I was just expecting or praying that one of these three who had a linear as the final answer had a correct explanation for that. Unfortunately, no one stands out the winner in today's case.
Can we check for power? Like
Power can be a good one. Yeah. So power, but again, the problem with power is it is you will have to check the whole extrapolated thing. I think it matches. It matches. So if someone had done power, you are still in the contention. So, but I don't think anyone has. You have done power? Okay, I'll check your answers and then check. It's not outrightly not something that you can check.
it's exactly
Yeah, it goes like this and then it sort of matches. Yeah. Any questions before we finish the class
So
today?
I have one.
Media was not an information, and it was this point of
Correct.
it's just the media one can be used.
Correct.
And from the hundred and me
Polynomial always. Because linear, you know how it behaves, right? Because linear, you know either it can increase or decrease. So you have an idea of how the trend will behave as X increases. But polynomial, until unless you know the trend, that's why you have to check how the polynomial behaves, how logarithmic behaves, how exponential behaves, and then see. The answer to your question is you have to check the R square. We can't say that linear is out of question. Let's say even if linear is 0.8, 0.85 also, you can still consider linear. So it depends on how you see that extrapolated trend. In case of linear, we know the extrapolated trend is always like this. It will never come down. It will never go beyond zero. So you know in your head, oh, this is linear, and if I consider or assume it's a linear relationship, I'm not doing a crime in the forecasting. So good question. Anything else? So yes.
what is the value that you predict? So for 26.
Oh, so I can work out that. If I would have done this, I would have done a daily level forecasting first, probably with the linear data because it is linear, filled in for the remaining 3 days, added it to the week, and then do a linear forecasting on the next week. So it's pretty accurate, which will be very close. Yes. Okay.
I actually did try to find each.
Okay.
What is the balance?
Negative.
Yeah.
How to figure out the day values?
So day value is very simple. If you are assuming it is linear, which now we know, even when you drag, you'll get the missing
But it's
pieces.
two different.
Sorry.
Because like the day values, it's not like very gradually, it's 92, 94, 94.
Correct, correct.
But we drag, it shows like more than 100 and it's like 405.
Even for the last value?
Yeah, it's
See
not
that,
similar.
we can see that now.
Again, one. Actually, difference is there. When compared to the last 6 8 difference.
Two.
And that's also because if you see the trend, and that's a very good question. So if you see the trend, in many cases, the similar numbers are quite repeating in bulk. So for example, if you see 43, 44 are repeating here, 45, and that's the thing. See, if you see 45, then 47, then it comes back to 45, which means there are ups and downs in between. So it takes that trend also into consideration. So it's not that it has been ever increasing. If it has been ever increasing by only 1, 1, 1, 1, 2, 2, then the prediction would have been 19. What was the last value? No, the last known value. 94. Yeah. So it would have been around 95, 96 if it was constantly. But the trend has not shown that constant up because there are ups and downs in between. It takes the overall trend into consideration. So I would still investigate. I would see if there are any other distributions which are also valid for daily level forecasting and see the graph. I haven't plotted. I was just assuming that everything is linear, but we can do that. So we'll plot and see what it is, where the trends are up and down, and whether linear is actually the best fit or not. And we can also see it from an equation perspective. So if we do the equation, if we put the value of x, how does it behave? But overall, it's not absurd. It's not that it is giving 120 or 130. Given the ups and downs of the trends, which have been continuous, it takes that into consideration. But it could be okay. I will investigate.
So we could go with this one.
We can go as of now. So unless I haven't investigated the actual graph and points, but assuming this is fairly looking linear, track can give you a linear. Any other questions?
For example,
In the equation, so when you put the linear,
what value should I
whichever week you're predicting. So right now I deleted the last week, so I put the value of x as 26. The main data. Yeah, so in daily level data, when we select, it automatically goes 1, 2, 3. So that's why we're not selecting the date. Yeah, we see the number. So first is considered 1, second is 2, third is 3.
like that? 21 of which is 180. And I will try to clear and still I got like
No, that makes sense. Then I see.
numbers. 180.
Fine. That is your next, that's 180 and 3. Okay. Okay. Second one. Until 180 is there, right? Okay, so we are ready for what?
I understand the body was shaking and you know where is the area. It is a halal.
The problem is when you plotted the graph, I would rather plot it with the numbers.
What is general change to the
That's the problem. That's the split dates and the equation is considering dates and things. I tell you what is happening. When you select this, for example, 94, right? What is? Others, if you have completed, you can leave. No problem. I'll see you next week.
You want this difference where you live the meeting of
Signed.
I showed you my idea.
So in the earlier case, it was actually date as variable, and then it becomes complicated because date cannot be. When you are plotting between X and Y, so when you average the trend line, it is X axis. Because now you put whatever value of
But
slightly Yes. It plots in the right way, but when you add trend line on that, it considers. Now it should only do 1, 2, 3, 3 enough. You need to check that because sometimes you might take your credit as the X. So always for being safe, 1, 2, 1 to study. Yes, so like you said, like upward. What problem? Now when you say linear, we never say that it will never go up. What we say, the trend doesn't match the general increasing trend. Okay. So let's say now there are some data points above this, there are some data points below this, there are some data points above this, below this. So overall trend that you see is moving in a linear fashion. That's what we see. Data will always go up and down. If it goes up and down like this, like a hyperbola up and down, that's not data. Then you're looking at probably a polynomial with so it can go up and down, but the trend is it check whether so we have to compare with the linear this is why for example, see the actual up and down, it looks like a balance. So which means it's going up, all the way down, going up, all the way down, that's a different here you see the trend is overall like this, some might be above it, some might be below. So up and downs are okay. As far as the trend follows the linear. Attendance for
I was taking start with
you can scan.
Thank you, sir.
Thank you, take care.
So I need to log in now.
Yep. Anyone else for manual attendance? Let me know.
Sir?
Abhish? Yeah. Anyone else?
Yes, sir.
Sir?
Yes, sorry, online students, yeah. Just
Yeah,
1
Yes,
minute,
sir.
yeah.
Me too, sir.
Online students, I'll mark it. I told you, right? We have a form by which you can fill in. I'll send the form soon.
Okay,
Okay,
sir.
then. Thank you.
Okay, yeah, all right. Yes, guys. Okay. Monday should be a good time. I don't teach on Monday. Monday morning after. Yes, my office is block 1630. Yeah. All right. Yes.
I don't know if you told, right? I was looking, but I couldn't find that.
Kaggle?
Yeah, it's Kaggle.
Yeah. No, but Kaggle. Yes.
Yesterday, somebody had that.
We will be doing that for you also. So that's a data IQ academy certification.
If not for all.
No, no, it is for, so basically we have education alliance with them. And if, so I'll be telling you the exact certifications to do. If you finish those 3 certifications, then we give you overall Middlesex cross data IQ certificate. Yeah, so this is the original data IQ one. this is not the Middlesex cross data ID. So if you get 3 of these, which I'll tell the links and everything, then you get a Middlesex. We will announce. Everyone.
Thank you, sir.
All right. Yes, sorry.
So I'm not from the AI background, but I just know how to play with the prompt and
Okay.
get why.
Okay.
So with the we were doing it now. Instead of doing for the 27th day, what I did was find the three missing data for the 26th and then finish the 26th week only because I didn't go for the 27th.
Correct.
And what I did see is you asked me why did I take the last 35.
Correct.
So if when we see the trend, it's actually like there are two different phases for this trend.
Mm.
So one phase that climbed from 19 to 20, the initial 4-month period.
Correct.
And the second stage was where it was steadily cruising in the 93 sales level. That's why it was the last
One, which is okay, and there is nothing wrong. So even, there are few other explanations. So sometimes people say that your recency will count. So you take only the last 10 days, take the average. Exactly. So multiple ways. So as far as you have checked that box, it is fine. You have taken care of the missing, right? Then the distribution, did you take linear or something else?
Linear.
Linear.
Yes.
Oh, you had linear?
Yes.
Okay. And any reason?
Because you were discussing for the like discarding the 26th week and doing for the 27th.
Okay. I will check. I'll check the packet.
I took linear for the data
Okay.
the data and
Okay.
I finished the 26th week. It
Okay.
came out around 655.
Interesting. Okay.
And the 27th week came out to be 672 units.
Okay. And you have mentioned that in the form,
I
right?
mentioned that in comments, like additional comments.
Okay. Done. I'll check and then I'll declare the winners.